All right. Now, why we're doing this today, I want to refresh your memory on how to find distance. This is the thing we introduced yesterday, the distance formula. I'm going to put that back up on the board. We're going to go through an example of it. If you have a calculator, it might be a nice thing to have that out, or if you want to go borrow one, I have plenty. That way you can like type some in. That way you can get a sense, do you even know what you're doing still? Because I know that was a brand new topic yesterday. It was the one I was kind of worried about, because the formula is kind of intense. It's very different than all the rest of them. All right, so on your graph paper, we should be possibly in what, our third picture?
Yeah.
Third? Okay, third picture maybe if you've been taking all the notes up to this point. Let's go with point M. Let's go with 1, 4. And point N. Let's go with 3, -5. Okay, so those are my 2 points. We're going to try to find the distance between. Okay, we're going to try to go with the distance between these two dots. Now, just to recap, let's talk about how do we draw these. Now, with point M here, 1, 4, what quadrant is it in? 1, 2, 3, 4? Kind of idea. Which one? 4. 4?
1. Oh, wait. 1.
Right.
Top right. Okay, it's in 1. Okay, top right. Okay, 1, 2, 3, and 4. So we're on that top right quadrant. So hopefully we're drawing the same dot, right? So 1 over, you have to pick your elevator, then you can go up and down it. So I'm picking the elevator to the right, because again, this is my lobby, and then I'm going to the 4th floor. So here's letter N. Letter N, what quadrant is that in?
4.
4, all right, so 3 over, -5 down. So there's letter N. N. Okay, and what we're trying to do here on this particular problem is figure out the actual distance between the two, the length of that line. It will be a crazy decimal because we're going diagonally. I'm predicting it will be a decimal. Anytime you go diagonal, it usually ends up being that way. There's a couple of rare cases where you might get a nice number, but this is where we have to use that formula. Now, up here, which numbers are my X numbers?
1, 3.
Okay, good. Yep, X's are in the front, Y's are in the back. It is literally called an ordered pair because of alphabetical order. So we're going to plug these numbers in my formula. So I'm going to put the formula up here. We'll kind of walk through it one more time. And then if you have a calculator, it'd be a nice thing so you can type some of that stuff in. Okay, so distance equals square root. We're going to subtract the X numbers and then square that answer. That means you're going to take it times itself. That should guarantee that you get a positive number when you square it. Okay, then what we're going to do is we're going to subtract the Y numbers. And we're going to square those. So Fox, you're just walking in, graph paper, draw these dots, we're going to find the distance. We're refreshing what we did yesterday. Okay. So, does that make sense, the formula itself? It's up here if you need to see it. I have all the formulas still written. So, we talked about my X numbers are 1 and 3. Does it matter the order I put them? Not at all. Because when we subtract them, we're going to square it anyways. It doesn't matter what order you want to put them. So since my X's are 1 and 3, I'm going to go 3 minus 1. To me, that makes more sense because it does not matter the order you put them. Okay, once I subtract those, I'm going to square them. Now, for the Y numbers, what are my Y numbers up here? Yeah, let's go 4 minus -5. Then that's easier because it will cancel out the negative sign anyway. And then we're going to take the square root of it. Okay, so now, doing the math here. 3 minus 1. 2, so that's 2 squared. 4 minus a -5. 9, and we're going to square that. Don't worry about negatives, they're going to go away anyway, so if you have negative numbers, just get rid of the negative sign, doesn't really matter on this one. 2 squared, this is where you have to take the number times itself. So 2 times 2 is? 4. 9 times 9? 81. You're going to add those together, and that's the square root that you're typing in. So square root of 85. So 9.21954. Okay, there. We'll stop there. Okay, how we're getting that number? Like, how do we know it's 9.2 on a calculator? The square root of 81, because what square roots are, it's what number you take times itself that gives you that number. 9 times 9 is 81, so it's just above the number 9. Now again, how you type this in your calculator is you have to find the square root button on there. So on my calculators, to type this in, you're gonna hit the little second key, which is, I call it the shift key. Then you're gonna go look for the x squared button, because above it has a little square root key. That's how you type it in mine. Then you can just type the 85 behind it. Now, some calculators are different. Like if you have your own personal one, you might actually have to type in the 85 first and then hit the square root key, because maybe you just have the square root key, and it'll just tell you what that number is right away. Does anyone need help typing that in or doesn't quite understand how to do that? Okay, because again, this is the time. We've got to figure out how to do it in your own personal calculator. So if you, a little square root key down, type in 85.
How close you can get to 85?
Oh, geez, hit the little S key. ST is like standard answer, decimal answer, we want decimal.
Okay.
Right there. That's the square root button, that's type of 85. Enter. Okay, so you got that. You want the little ST button as well. That's right there, that's the button. Because that goes from like standard answer to decimal. Boom, but that's fine. That's not, those are really nice. Yeah, those calculators can do more than my $100 calculator desk. No joke, those are seriously. We're getting great. Like seriously, those things can do some serious math. I'll explain that later. When we get to like later stuff, those are nice. Okay. Anyone else need help typing it in? Okay. So, what this is, what we're getting, like what is this 9.2 number? That is the length of this stick. This stick is literally 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9.2 spaces long. This stick and this stick are the same size. That's what it's saying. That's what that decimal means. Okay, does that make sense what you're doing there in the homework? The big thing on the homework is recognizing when you first look at a problem, is it a coordinate or is it a number line? Obviously with these are coordinates, right? So there's only 2 formulas I can fall back on. Midpoint or distance. Read the instructions. What does it want? If it's giving you a number line, you only have 2 formulas. So know which thing it's asking for, know the formulas that you have. Okay, are we good with that?
Yes.
Okay, now today, once we have some work time, the goal today is to give you about 20 minutes of work time. When you get there and you need help on these, do not be afraid to ask. I want to give you time in class so you can ask me questions if you need to. Because I don't want you being lost. I want you to feel comfortable with what we're doing here. Okay, are we good with that stuff? Good, let's put that all away. Have your pencil out. We're going to do a new construction today. So it's going to be based on midpoint. Okay, so we have construction number 2 that we're going to do. I will provide you the paper that you're going to need. So everything can go down below you, except for a pencil. Yeah, we're just going to do a couple notes and then we're going to give you some time to work. Okay, now the paper I'm going to hand you, the graph paper. There's 2 sides. There's a blank side, there's a grid side. I want you to go to the blank side of the paper and put your name on it. You are going to turn this in for points. So everyone should get a piece of paper. Put your name on it. So, I mean, 4 or 5.
Is that warm?
That's
You playing on anything?
Alex, it's water. It's all over me.
No, warm.
Might be too bad.
I'll dump it on your paper.
Need some water.
Good? Everyone's got one? Okay, everyone have a piece of paper. All right, put your name on it. Remember, go to the blank side, not the grid side. You want to go to the blank side. I don't care how you want to orient it. I don't really mind. Okay, first thing. Again, the goal here is to talk about midpoints. Okay, you got a ruler now. Everyone's got one. Okay, here's what I like to do. On your piece of paper, okay, on your piece of paper, I don't care where you put this. I want you to take your straight edge, go to the side that has the centimeters. That's the one that goes up to 30. So figure out that side. I want you to draw a segment, a line segment that is exactly 10 centimeters long.
In the middle or on top?
It doesn't really matter where you want to put it. I'd say probably not in the middle. We're going to draw another picture here. So maybe put it near the top, but it doesn't have to be anywhere specific. But draw a segment that is exactly 10 centimeters long. Let's call that A to B. So again, the goal here is to draw a segment AB that is exactly 10 centimeters in length. Then again, now, we're not going to have you measure your neighbors. Just look over at your neighbor's picture. Does it look roughly correct? That's all I want to make sure. Because there should be a certain length. If it kind of looks like yours, you're good. So I'll check yours out. Looks good. It looks fine. Okay. Everyone's got a line? Anyone questionable on their drawing? Okay. All right.
Alex seems very questionable.
All right. Here's the thing. You have a ruler, right? Find the midpoint. You have a ruler. Without saying anything, don't say anything to your neighbors. Find the midpoint of that segment. Don't say anything out loud. Just find the midpoint of your line segment. You have a ruler. It should be pretty easy. Let's label it M. M for midpoint. So here's my question. How'd you do it?
Okay, 10 divided by 2.
Yeah, 10 divided by 2, which is
5.
5 centimeters. So if you went over 5 centimeters and 5 centimeters, whatever way you went, you're golden. You hit the midpoint, right? You hit the direct center. That's easy. I want your rulers now. Okay, these are rulers now.
Can
I
I
know I
just-
just handed these out.
Wait a minute. Can I use another type of straight edge to measure that?
I know.
I'll learn how to
Them all back.
correctly.
Send them all back. Them all back. You got them all in.
Mr. Owens is
Some of your self, I can tell. Give me that ruler back. Knew it.
to the 60.
All right, everyone's got them? Okay,
How do you do this?
Straight edge.
so
Impressive.
next, we're gonna go somewhere else in your paper now.
You could have made us do it.
5, 6.
You could have made us do it the hard way.
1, 2, 3.
Could have given us 3 types of straight edges.
All right, now if you did not get a straight edge, let me know. I'll give you a straight edge because some of the bags might be missing one. Anyone not get a straight edge? There should be an extra one in one of the bags. Is that it?
Thanks, Dad.
Need a straight edge? Who needs one? Over here? Everyone's got one? Or does somebody have an extra? Okay, there was one bag that was missing. Okay, here's the thing. Pick up the little straight edge, that little black zip tie. Okay? Now, it is a straight edge. It's a flat object that you can draw a straight line with. Don't bend it, don't mark it, because there's supposed to be no markings. I know there's the little ridges on it. But here's what I want you to do. Go somewhere else in your paper and draw any segment you want within reason. Don't go all the way across the paper. But try to make it different than this one. So just draw a segment somewhere else in your paper that is, give yourself some space. Don't put it at the very bottom. Don't put it at the very top of the paper. Don't put it right next to this one. Give it some space. We're going to draw around it. And what I want you to do is draw a new segment of a new length. And let's call this one C to D. So again, you're going to need some space around it. So don't put it near the top or direct bottom. And don't draw it too long. That'll make it more painful. But it can be any length. It does not have to match the other one. Oops, sorry.
The lead on my thing.
Oh, yeah.
Yeah, so it's 4.
Oh, jeez. I didn't realize that. Okay, I'll take your bag. Where's that other bag? Yeah. All right. Okay, hey, does everyone have their new line segment C to D? Everyone's got it? Okay, here's the idea. Okay, you drew it with a random straight edge. We couldn't measure this. But what we're going to try to do is find the mid segment. The midpoint, I should say. We're going to try to find the midpoint of this thing. So here's what you need to do. Pick up your compass. Now, if you're following my rules specifically, you'll be fine. It's pretty easy. If you're in drafting, you probably already know this one. If you're not in drafting, this is probably new to you, so you get to figure out how to do this. So here's what I like you to do. Take your compass. You're going to put the little pipe, the little pointy end on letter C, and you're going to open up the compass random. I'm not measuring at all here. All I want to make sure of is when you open up the compass, you are past the visible about halfway point. Halfway to me looks like it's around there. You don't need to mark that. I'm just like visualizing where the halfway point is. Open up your compass so you're past that. Not all the way, just past halfway, where you think halfway is. Do you agree this is past the halfway point? Okay, so I'm not measuring at all. It just has to be past the halfway point. Okay, we good so far? Again, now when you actually set your compass, like this, where it's past the halfway point, you will not change this compass ever again for the rest of this drawing. You're going to keep it exactly this length, even though I just randomly opened it. Okay, so pipes and letter C, correct? You're going to make a mark above the drawing and below the drawing from that letter C. Now, how do I know where to put them? They have to be above where you think the middle is. So make those marks above the middle. Now, if you're drafting, they teach you not to pick up the compass. So you would actually physically drag it so it would do like a crescent moon like that. That's what they teach in drafting. I don't require that you do that. So you're just going to draw the arc above and below by just holding the compass where you're at. It has to be above the middle. Again, this was random, right? I didn't measure this at all. Everyone understand how you do that? I'm going to get rid of this. Now, what I like you to do, flip the compass around. Don't change the size. Leave the compass exactly how it is. Put the pipe in letter D and make the arc above and below. And when you do this, it should make X marks the spot, where X is above and X is below it. If you did not get that, just take your compass, turn it around, and go from letter C again and extend those a little bit further. Flip it around to letter D, but you should make two floating X's out kind of in the middle of nowhere, above and below it, correct? Does anyone need help? Now, if your line, let's say you couldn't draw both X's, maybe it's off the paper, go redraw a line so you can actually do it. Put the line somewhere else, so you have a room above and below. Questions so far? Everyone's got it? Take your straight edge now. Take your straight edge. Draw a line that connects the X's. A straight line that goes right through the middle of both X's. There it is. This spot is the perfect middle. Whoa. Works every time. Now, most people can't figure out, like, why does that work? Because it's completely random, right? I didn't measure anything. I opened up this compass past the halfway point and did it. Here's why it works every time. It's because you're making the distance from C to this point and D to this point the exact same distance. This is like the middle between the two, right? Because you made the distances the same. You did the same up here, because this is the same distance right and left. So these are above the middle, because they're literally the average between C and D. So when you draw the line, it is still the average every single time. And so that's why it's going to go through letter M. Now here's the craziest part. It did go right through the midpoint. This is the direct midpoint right in the middle of that segment C to D. But even crazier, this angle that it made right here is perfectly 90 degrees. It is a perfect L shape. And the best news is, and this is the reason why we're doing this, the line that we just drew that connects both X's has a special name to it. This line that you just drew connecting both X's is called a bisector. A bisector is a physical line. It's an object in geometry. It's a line, ray, or segment or plane but it passes through the middle of a different object. Do you agree that my bisector passed right through the middle of C to D? Okay, if it passed through the middle, then this line would be a bisector. There's a difference between midpoint and bisector. Bisector is the physical object cutting. The midpoint is the dot at the center. Do we see the differences? That's the idea. Okay. That was your construction today. Make sure your name's on it. We're going to turn this in. This is your second construction you've ever learned. The first construction we did, you copied a segment to a new spot without a ruler. This one is where we can cut segments in half now. Perfect task. Okay, put your compasses and the straight edges back in your little baggies.
So then, is the bisector where the line, like the lines?
Yeah, so the bisector is the physical line. This line is the bisector. Okay, I'm gonna collect the papers from you. Make sure your names are on them. You're gonna get points for doing those. And I'm gonna collect the tools here in a second. So make sure they're back in the bag. If you had too many straight edges, one of the bag has 2 straight edges in it. I need to know that because I'm missing one.
Bag.
Collect the papers.
It's gone and lost.